Okay, so this is a short video tutorial on how to solve friction problems. So the typical friction problem, you are given an object sitting on a horizontal plane, such as a box sitting on a table, and you're asked to calculate the friction between the box and the table. To do so, you have to be given a couple things. In this case, we would be given that the mass of the box is 3 kilograms, and we say we pull with a force, a pulling force, so I use FP in the subscript for pull, of, let's say, 7 newtons. So, the first thing I'm going to want to do is I'm going to want to draw a free body diagram. So I'm going to go down here to the middle of my page. I'm going to draw a box to represent that book. I don't draw the table on a free body diagram because this is only the forces that are acting on the object, being the book on the table. So I draw a dot for the center of mass. All forces begin or originate at the center of mass. Gravity, as we all know, acts on this object. The force of gravity, force, subscript little g for gravity, pulls the object downward. Since it is not accelerating downward, it's sitting on the table, we know that there must be a balancing force. That balancing force is equal in magnitude and opposite in direction as the force of gravity, and that is the surface force, often called the normal force, F sub m. I'll write normal force right out here to the side, and this is the force of gravity, or let's write force of weight. Okay, so that is a stationary object. If the book was just sitting on the table, that's the free body diagram that we would have. Now, we said that I pull with it to a point where it's just before it's sliding. So I'm going to draw an arrow that represents me pulling on this object, and I said there is a F sub P, P in the subscript for the pull going to the right. This is given to us as 7 newtons in our given information. And if the object is not moving, and that's right at the point where it's the last point before it starts to budge, that we know the maximum amount of friction must therefore be 7 newtons. If it's not moving, something has to be balancing this force of me pulling on it this way. So what is balancing that force? It is the rub, or the friction, the force of friction between the book and the table. We know these two are equal because the object is, again, at rest horizontally. So this object is at rest vertically. The force of weight and the normal force are balanced, and it is at rest horizontally. The pulling force and the force of friction are balanced. So from there, how do we figure out the coefficient of friction, which is the stickiness, right? Which is what we want to know in the end. How sticky is the bottom of this book? So we have to do a couple of things. First step, part 1. You need to solve for the force of gravity. We need to know some values for this, right? We need to quantify this. We need to find the numbers for it. You solve for the force of gravity with the equation, Newton's second law, mass times little g. Little g is the acceleration due to gravity on Earth, 9.81 meters per second. So we can now solve for the force of gravity. We can also say that is more or less 10 meters per second. I'm going to use that today to make the math a little bit easier. So if we're solving for the weight of this object, we'd say the force of gravity equals, we were given that the mass of the object is 3 kilograms. So I'm going to put 3 kilograms in right here. Little g, 9.81 meters per second squared. And so when I multiply those, I find out that this thing weighs, or the force of gravity acting on this thing is about, I'm going to change this to approximately 30 newtons. So the force of gravity, or the weight of this object, is 30 newtons. If we go back up here, that means that the downward force on this book is 30 newtons. So we can add that in. So I'm going to redraw this free body diagram here to try and clean it up just a little bit. So I'll put the object right here, my center of mass, the force of gravity down, the normal force up, the pulling force to the right, the force of friction to the left, and now I can put some numbers in here. This, we know from earlier, is 7 newtons. So friction must also be 7 newtons. And now we know the force of gravity is 30 newtons. So what is the normal force? That's right, 30 newtons, just like you're saying in your head to yourself. Looks so much easier like this, doesn't it? So now we know these variables. Now we can go to the fun equation. This is your friction. Part 2. Here was part 1, solve for the force of weight. Now we're going to solve for the force of friction. Solve for the coefficient of friction. So how do we do that? With the fun equation. And the fun equation says the force of friction, F sub F, subscript meaning friction, it's a force, is equal to mu, which is the symbol for the coefficient of friction, times the normal force. If we now take this equation and we look at our free body diagram, we can start to plug these numbers in here. For the force of friction, we look back over here, that was given to us. The force of friction was 7 newtons. Mu, we don't know how, that's how sticky it is. That's the coefficient of friction. That's what we're looking to solve. We don't know that, so I'm going to leave that as mu for right now. And the normal force. Now, after doing these calculations, we know the normal force, and we can find it, and it is 30 newtons. We got that by solving for weight. We know that these two are equal, so the normal force is 30 newtons. Now we have a basic algebraic equation. 7 equals mu times 30. You could think of that as, 6 equals 2x, and you solve for x. We don't have 6, we have 7. We don't have x, we have mu. We don't have 2, we have 30. So to solve for this, we got to get mu by itself. So we divide this side by 30 newtons, and what you do to one side, you again have to do to the other side. These cancel out, so 7 divided by 30 equals mu. You plug this into your calculator, 7 divided by 30. That's probably going to be a little bit less than a quarter, so, or a little bit more, I guess. So 0.270. That's just an estimate. You punch it in your calculator, see how close I got. Come tell me if I'm wrong. Probably am. So anyway, that is solving for how sticky it is. So if we're trying to figure out the coefficient of friction between a book and the table, we would use this exact process here. If you were to look at something that's going to be stickier than a book and a table, right? If you put some sticky stuff on the bottom of that book, this coefficient of friction is going to increase, meaning it's stickier. This is how sticky is it? Mu tells you how sticky it is. Okay?